Okay. So happy Friday. Those of you that just came in late, it's okay. I'm not mad at you. At least you're here, right? Happy Friday. You might have missed the Friday song or just got the last end of the Friday song. All right, so how do we do this? How do we find the scale factor? Well, what is the scale factor? When I say scale factor, what am I talking about? Is my microphone on? Hello? Hello, hello. When I say scale factor, what am I talking about? The ratio, right? I'm looking at the ratio between the sides, right? I'm looking at the ratio of the corresponding sides. Very good. I'm looking for that ratio, right? And the ratio can be either way. It depends how you say it. So I said the ratio between the figures. So guess what? There can be two different answers. I didn't say from big to small or small to big, right? Usually the question will say from this one to this one or this one to this one, small to big or big to small. In this case, I didn't say what big to small or small to big. So you got to decide. So we'll look at both of them. Okay, so if you said from small figure to big figure, then that'll be your ratio. And they have to, now we got to see if the ratio is for all the sides. So let's see, small to big. So I'm going to look at the red side, small to big, so 8 to 12. 8 to 12. Okay, and what does that equal? Well, let's get another side. Let's do the blue ones. 4 to 6, right? Small to big. 4 to 6. All right, let's simplify both of those. What's 8 to 12? If I simplify 8 to 12, what do I get? Well, what can I divide 8 and 12 by? I can divide by 4, right, and I get 2 over 3. Good job. So I divide by 4, I get 2 over 3. And let's do the same thing for the blue. Divide by 2, and I get 2 over 3. Ding, 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 ding. Hold on, where is it? 2 over 3. So you can say in a sentence. Now we can test it now. Some of you that are thorough, some of you are like, Mister, that's not enough. Okay, if that's not enough, let's go on. Somebody wants to be really thorough, you can look at the purple ones. What's purple? 15 to 10. Ooh, you wouldn't say 15 to 10, would you? Right? Some people do that. Some people say, oh, 15 to 10. What's my mistake right there? What mistake did I just make? It's yeah, right. That one's big over small. That's not what we're doing here. We got to see how are we comparing? You always have to look back and see how you're comparing because order matters. In this case, we're saying small to big, so it should be 10 over 15. And if I divide by 5 on both sides, I mean on top and bottom, numerator denominator, I will get 2/3. And if you're really thorough and someone in the chat says, hey, mister, I sound like that. If you're really thorough and you say, I want to do the green ones now. That's fine. Let's do the green ones. Small to big, so 6 over 9. And if I divide both of them by 3, right, I will get 2/3. So we can say in a sentence, the ratio of small, and those are four-sided figures, so we can call them quadrilaterals. Of small quadrilateral to big quadrilateral is 2 to 3 or 2 to 3, 2/3. Which means you can say the small one is 2/3 the size of the big one. That's what that ratio tells you. That's what that's the rate that it grew. 2/3. But mister, yes, I don't like the small on the top and the big on the bottom. I did big to small. Well, that's fine. That's fine. So let's look at that, big to small. So that means you did 12 over 8. That means you did 6 over 4. That means you did 15 over 10. And that means you did 9/6. And so if I simplify those, guess what I get? 3/2, 3/2, 3/2, 3/2. Okay, and they all should match. All these ratios should match because they're growing or shrinking at the same rate. So you can say in your sentence, the scale factor. Oh, I said ratio up here, huh? I said ratio up here. You should say scale factor because that's what they're asking for. Same thing though, right? Those two words mean the same thing. Okay, I see a question in there. I'll answer that in a second. The scale factor of big quadrilateral to small is 3/2 or 3/2. And 3/2, if you did the math, is 1.5. So you're saying the big one is 1.5 times bigger than the small one. And so the question was, Mister, how do you know when to do small over big or big over small? Usually the question will tell you that. The question will tell you that. It'll say, like we did over here. Remember over here, where is it? Yesterday's notes. Like over here. Remember question 1 said from ABC to DEF? Well, ABC is the small one and DEF is the big one. So this one's going from small to large. And then the second question said from DEF to ABC, from large to small. So the question will usually tell you how you're going. Large to small, small to large. Okay. All right, I'll give you a second to copy this down, however you did it. Now, again, I know if it's blurry, I'm sorry. That's just how Zoom is. Again, you can watch the video. I didn't upload the video yesterday. I was having trouble with my internet, so I'll upload yesterday and today's videos today. Okay, so if you're having trouble, I will upload those today. Today what we're going to do is I'm going to show you two things, right? I'm going to show you two things. Then you're going to start on some classwork. And then Monday you'll finish the classwork. The classwork is in Schoology. And there is homework in Schoology too, which you'll work on, and that also is due on Monday. So we're going to start the classwork and homework today, and they're both due on Monday. And again, after Monday, if you say, hey, mister, I need an extra day, that's fine. You can always ask me for an extra day. Okay? So this is what I'm going to show you today. So we've only done these two boxes. The top green box was talking about similar polygons. We defined what similar polygons are and the two criteria. There's two things that have to be true for figures to be similar. All the corresponding angles have to be congruent, right? No angles can change because if you're changing angles, you're changing the shape. And then the sides have to grow and shrink at the same rate, right? And rate is just short for ratio. And so if you have the same ratio, that means it's proportional. So they have to be proportional. That means they have to grow at the same rate. And then scale factor, we talked about scale factor is finding that rate between the two figures, finding that ratio. It's called the scale factor between the two figures. And then the order that you do it in, the ratio top to bottom is really usually told to you by the question. Okay? So how do we write similarity statements, right? So now how do we write similarity statements? Well, first of all, similar has a symbol, and it's like this. It's a little squiggly line like that. When you see that squiggly line, that means two figures are similar. Like you can say triangle ABC is similar to triangle DEF. Or quadrilateral HIJK is similar to quadrilateral MNOP. Okay? Or pentagon WXYZ. I ran out of letters. A is similar to pentagon HIJKL. Okay? That little symbol just means similar. And so it says, write a similarity statement for the triangles above. Oh, we just did, didn't we? triangle ABC is similar to triangle DEF. And remember, the order of the letters matters. Just like it did with congruent triangles, it matters here, right? It matters because AB and DE, those are the first two, they correspond. BC and EF, they correspond. And AC and DF, they correspond. So the order matters when you say your similarity statement. That's it. That's it. When you have two figures, that's how you write a similarity statement. Everyone clear on that? You just say the figure is similar to the figure and make sure the letters are corresponding letters. Okay? Just like we do the congruent. So if I look here, let's write, it says right here, we're going to write, there's a similarity statement right there. We don't have to write it. There's the similarity statement. Now, looking at the similarity statement, it tells us everything we need to know. It tells us everything we need to know. So what they want us to do is list all the congruent angles and write a proportion that relates the corresponding sides. Okay, so let's look at the angles first. What do we know about the angles? If these two are similar, and that's what that says, these two are similar. What do we know about the angles if these two figures are similar? The angles are I know everyone's typing away right now to put the answer in the chat box. When two figures are similar, the angles are congruent. Woohoo! Yay, there you go. So here's the question. Looking at these two figures, I really can't tell what matches with what. Because this figure could be a rotation of this figure, right? This could be rotated, and I don't know which matches. It doesn't always mean that this and this match, and this and this match, and this and this match. That's not always the case. That's why we need this similarity statement. So what's the first letter here? J. What's the first letter here? P. So guess what? Angle J is congruent to angle P. Okay, we're looking at angles first. Angles first. Okay, what's the second letter? K. What's the second letter here? M. So angle K and angle M are corresponding, so we can say angle K is congruent to angle M. And then L and N are the last letters, so that means angle L is congruent to angle N. Those are the corresponding angles, so the corresponding angles are congruent. Okay, we can even do colors if you want to. And that's what we did last time, right? So J matches with P. K matches with M. And L matches with N. So it is, you see that? You see how like the second triangle is just the first triangle. It's rotated and it's actually enlarged. And you can see that too, right? You should always understand which one. This one's the small one. This one's the large one. Yeah? Okay, so now it says, let's put, now how do you want to do this? Let's write a proportion. You have to decide. It doesn't tell you which one. Oh, actually, this one's first, right? That one's first. Is that the small one or the large one? That's the small one, mister. Very good. It's the small one, yes. So small comes first. And then what comes second? Large. So let's write a proportion. So let's go from small triangle to big triangle. So let's do this. Let's do purple to orange. Purple to orange. You guys see that? Purple to orange. Purple. That's why I like to do colors, because it makes it a lot easier. A lot of you look at this and go, oh, mister, I can just look at this. JK and PM. Sure. KL and MN. Of course, you can do that. JL and PN. Those are all the corresponding sides. You can do that, but there's some people that look at letters and say, mister, I can't do that. I can't do that because I don't know. I just look at these letters and they confuse me. That's fine. Guess what's easier to work with your brain? Colors. So if you can't do that, then we can see the corresponding sides. Purple to orange. Purple to orange is JK. Purple to orange is PM. See that? Now let's do the next one. That should equal, right? That ratio should equal the other sides. Let's do small to large again. Let's do orange to green, orange to green. You guys see that? Orange to green, KL. corresponds to orange to green, MN. And that should also equal, what's the last one? Purple to orange. No. Which one we do? Which one did we not do? Green to purple. Very good. Green to purple. Right? So green to purple on the small, LJ. Green to purple on the large, NP. So green to purple on the small is LJ. Green to purple on the large, NP. And there you go. That's it. Okay, so all we did here was they already told us these triangles are similar. All we did here was show what was corresponding. The angles that are corresponding are congruent to each other, and the sides that are corresponding form ratios that are equal to each other, right? This side over this side, right? Purple to orange, that's a ratio. Equals a ratio of this one, orange to green, equals the other ratio, green to purple. Okay, does that make sense? We're just writing our proportions. We don't have any values. We're not solving for anything right now. We're just seeing what matches with what, right? And all the angles are congruent, and all the sides form ratios that are equal to each other. Okay, I'll give you a minute to soak that in and to copy that. I'll zoom in as far as I can so it's not as blurry. So the question was just asked in the class, Mister, you see how you went green, purple, and then green, purple? So you did LJ and NP. What if I did purple, green? What if I did purple, green? Is that the same thing? Yes, as long as you go the same way. Don't do purple, green, and then over here, green, purple. Don't say JL and then NP. You got it all. Order matters. So if you're going to go the other way, you could have said JL over PN. They both have to switch, though. They both have to switch. Yeah, you could have also said LK over NM. You could have also said KJ over MP. As long as you stay in the same order, right? As long as you stay with corresponding stuff, right? The J and the P are corresponding. The K and the M are corresponding, right? So that's a great question. Yes, you could have gone the other way. All right, so I'm going to have you do one. I'm going to have you do one on your own. See if you can do this. Let's do this one. So there's 4 sides now. So do number 3. Number 2 is a little tricky because the triangles are on top of each other, and we'll do that one together. But try number 3. So if you're having trouble starting, I kind of started off a little bit for you. I color-coded, right? Oh, someone asked, Mister, in the last problem, why didn't you do large to small as well? Because I went with the order the problem told me, right? Like in the warm-up, the warm-up didn't tell you which way to go, so that's why I showed you both. This one, the problem does tell you. This one's first, this one's second. So this one's the small one, this one's the large one. So that's why I went to small to large, because the problem tells you what to do. So if you look here, this one is first, this one is second. So this one is the large one, this one is the small one. So because of the problem telling us this order, that's what we're doing. Large to small. Okay? So that's how you know. Whatever this tells you, whatever order the problem's in, that's the order you do your proportions. So I just really quick. No, you're good. I just really quick did the colors for you, so maybe that'll help you. So I'll give you a couple more minutes to finish this one. All right, time is up. So yeah, as I was saying, I don't think we're going to finish today because this is just matching stuff up. Remember, this is matching stuff up, just making similarity statements. And We still need to get to finding side lengths. So now once we know, but we have to practice this because you need to know what matches. Before you can start solving for anything, you need to know what matches. That's why we're doing this. You need to know what matches with what. That's why I color coded this. And how do you know what matches with what? The order. J, Q, K, R, L, S, M, P. So I just put colors. Colors help with the brain. If you're just looking at black and white and you're trying to match things and you just keep it black and white, your brain's not gonna catch on as fast. If you start color coding things, your brain can see this a lot easier. So now that I color coded and I actually color each letter to that corresponding color, you can see now, oh, there's J and Q, there's K and R, green and green, there's L and S, orange and orange, there's M and P, blue and blue. So now I know. So the angles are easy. Angles are just what match, purple with purple. Angle J is congruent to angle Q. Angle K is congruent to angle R. How do I know that? Because they're both green. They're both matching in the similarity statement. Angle L, orange, is congruent to the other orange, angle S. And which one did I not do? I didn't do the blue. Angle M is congruent to angle P because they're matching up on the similarity statement. So now let's do our ratios. So let's just go around from here. Purple to green, right? We'll go purple to green, then we'll go green to orange, we'll go orange to blue, then we'll go blue to purple. We'll just go around in a circle. That's what I like to do. So purple to green, J to K, JK, purple to green, QR. That should equal green to orange, green to orange. Right. KL, RS. And that should also equal, let's go orange to blue, orange to blue. So orange to blue is LM, orange to blue is SP, right? We're going from the large to the small because they tell us that. That's the large, that's the small. And that should equal the last side, which is blue to purple, blue to purple, blue to purple. JM, I'm sorry, no, sorry. MJ, Michael Jordan, blue to purple, and PQ. Okay, does that make sense? So that's all we're doing here. That's all we're doing is we're matching up what sides correspond with what sides, setting up those proportions, and what angles match with what angles. Those are congruent. Is everyone clear on this? Is everybody clear on this? Show me a thumbs up or a happy face or a something. I need to see it. I see one person. Thank you, thank you. The answer is no to somebody. Okay, good, good. I want to hear the no's. So I'm going to pause really quick so you can ask me, because I know you like to ask verbally. All right, so I'm back. So those of you watching the video, like, you didn't go anywhere. You just paused it. Okay. The question was, how do I know? Like, there was just confusion about generally about everything, right? How do you know what matches with what? And this is a similarity statement. It's basically a statement telling me what is similar, and the order matters. So the first letter here matches with the first letter there. That's why I colored them both purple. Second letter here matches with the second letter there. That's why I colored it green. Third letter here are orange. They match because they're both third. Then the last letter matches because they're the last ones. And so that's why I color coded it. Then the question was asked, okay, then how do you know how to put this in that order? And I said, okay, well, this is first, and that's the large one. This one is listed second, so that's the small one. So we're going large to small because of this order. This one's the large one. This is the small one. And so that's why I put large on top and small on the bottom. And then I just create my sides. Remember, we make ratios comparing both sides, the large side to the small side. So I just picked purple, green, purple, green. And if you look at purple, green on the large one, it's JK. And if you look at purple, green on the small one, it's QR. So there's my ratio. And then next I did green, orange, green, orange. And green, orange on the large one is KL. So I put that on the top. Green, orange on the bottom one is RS. I put that on the bottom. And then I did the same thing with the other two sides. Okay, so all we're doing right now is we're figuring out what matches, because if you don't know what matches, you're not going to be able to solve for sides, because that's our ultimate goal. We want to be able to solve and find side lengths. Okay, number 2 I skipped just because and I know we're out in about 3 minutes. I just wanted to show you, if you look here, there are 2 triangles, but they're on top of each other. And they're both similar. So I'm not going to do the whole problem, but I want you to see the 2 triangles. The first triangle is XYZ. That's the big triangle right here. You guys see that? That's the big triangle. And then the other triangle is RYS. That's this small triangle, but it's on top of the big triangle. So what I like to do in these cases is I like to draw the separate triangles. So there's the big one, X, Y, Z. Right? That's the big triangle. And then I like to draw the small triangle separately. R, S, Y. And that's my second triangle. Right? I just like to draw them separately, because on top of each other, when they're on top of each other, a lot of students get confused. So what I like to do is separate them. There's the big one. There's the small one. Now, they kind of don't look that, so I would draw this one a little smaller so you can tell it's the small one. And then I would go from there. All right, so class ends in a minute. So we're going to continue this on Monday. The homework, don't start on the classwork. The classwork is in Schoology, but don't start on that. We'll do that on Monday. But you should start on some of the homework. You can do some of these problems. With the matching stuff, you can do the matching stuff, and you can do the scale factor stuff. You are not going to be able to do the side length stuff unless you figure it out. But you won't be able to do the side length stuff for right now. We'll talk about that on Monday and Tuesday. Okay, sound good? Okay, yeah, I'm sorry, guys. But yeah, I wanted to explain this. This is very important. Knowing what matches with what is hugely important, because if you don't know what matches with what, you won't be able to solve. So we will continue this on Monday, okay? And if you have any questions, let me know. You can start the homework. It is in Schoology. You can use Kami. It is there. So let me know if you have any questions. Other than that, have a great weekend. Have a great rest of your Friday, and I will see you all on Monday. Take care, guys. 14 more days till spring break. Woohoo! All right, take care, guys. See you Monday.